Right, this is a quick and simple video to tell you how you can actually upsample your file. Why do you need to do that? It's because you may have a file that is pretty small, like maybe 50 megabyte, 80 megabyte, and I can tell you with 80 megabyte it will not be sufficient for you to run on the cluster because it's small. So most likely one single node would be enough to run it. So the better way to do this is to use a technique where you can upsample your file. Okay, in order to upsample, there are a few ways of doing it. You can either read line by line and start duplicating the output. That means as you read a line, you can maybe write it 10, 20, 50 times in the output. So that's one way. Secondly, the easier way is to use a script like what I show you here. And you can see if I have a file now, let's say in Shakespeare, and okay, let's just put in H so that it's human readable. You can see there are 4 files, right, that can be used for, let's say, your word count example. But obviously at 1.7, 1.8 megabyte, it's just pretty small. So what if I can duplicate this file? Right, I can make it bigger, like 10 times, then it would have been 18 megabyte. And if I make it 100 times, then it's 180. Yeah, so this is the principle I would like you to try. And of course, the easier way, as I mentioned earlier, you can just read the file and duplicate. But the danger of doing that is you are using your memory and you are reading line by line, and that process will be pretty slow. You can even copy and paste using Notepad, but that's definitely not the way I would recommend you to do it. So we're going to use a script, right? And using that script, you will duplicate the file. Imagine you just make sure a file is being added to the output file again and again, and it will repeat up to the number of times you are interested in. So that will be the technique we will use now. Yeah, and I'm going to show you how you can do it. So let me show you a script that I've written, and if you look at it, you see it's not really long. Okay, first of all, there are all the libraries. It's a technique that uses the shell utility, and you definitely need to start by defining where the source file is, okay, and also where you want the file to be written, which is a destination. That's why you can see I have the second line here, and we call it upsize comedies. Then next, you want to look at the destination. So you define that it will open the destination file with the flag WB, means you are writing it as a binary. So that is where you want to be written. Okay, and with that definition, next thing you do is you define how many times you want this file to be duplicated or copied. Yeah, so for example, I put 1000 here, so I want it to grow 1000 times. Next, it's just basically a for loop that will repeat as many times as you have defined. And more importantly, you can see you use the shell script to copy the file by reading from the original file. That's why it's RB, just reading as a binary, and save it to the destination, which you already put WB, means write, append to the original file. So it's not the original, actually the destination file. Okay, so let's run this file, and of course we're doing it 1000 times, so it will not finish within the next 2 seconds. But even for a 1.9 megabyte file or 1.8, I can't remember. Okay, it wouldn't take even more than a minute. So very soon you see it's done, and let's check the file size now. You see, if you check the file size, this file, after 1000 times of copy and paste, you would actually end up with a file that's as big as, yeah, not really surprising, right? It's about 1.7 gig. So that is how you have upsampled the data. That in this case is okay because we are not upsampling to retest accuracy or get a more accurate word count. We are just treating like as if this file is that big, then you can do the comparison of running this with a standalone code without MapReduce And you can also run it with MapReduce or even different approaches like using Pig, like using Hive, and again see how the different modes, what kind of performance you have for a 1.7 gig file. So remember, to do this, I would encourage you to also run this script on your Hadoop masternode. Don't do it on your computer and then you have to upload 2 GB of file to your AWS. You can do that, but I think more efficiently is to upload that, let's say 20 MB to your AWS, and then run this script on your masternode to change it to a 2 GB file, and now you can use that as your input data in order to run your different sets of evaluation. And with that, you can now tell how well different approaches work. And I think you should be able to also compare, observe, and see how whether Hadoop does bring you any of these advantages as we have spoken about. So with this, I hope you can, try out this thing and also get your assignment done successfully. So till we see each other again, have fun learning, and I'll see you in the next video. Bye!